protocol, Subspace protocol sync meeting. We're going to start off with Ozgun going first and reviewing us on the GPU project, and then Nazar is going to start getting us up to speed on the latest PRs for the substrate implementation. All right, Ozgun, take it away.
Hello. Last week's issues were two compilation problems, both of them related to WASMore standard library of Rust. I was not familiar with them. After reading the related articles and resources, I was able to solve both of them and worked also weekend a bit. Now, at the start of the Monday, both compilation problems were fixed. So calling our slot library from anywhere in the Subspace library monorepo will not create any problem. We can use all the functions, and now we are also using them in actual plotting. This is also working really fine. GPU and CPU plotting is also working. I mean, whether if you have a GPU, then it will utilize CUDA. If you have CUDA GPU, it will utilize it. Otherwise, it will just use CPU for that. And it is also notifying you for only using CPU or GPU if it's found it's using GPU. After that, now node, plotting, plotter, and farmer. These were the two commands that I'm trying to run. The previous compilation problems were due to node itself. So when I tried to compile node, it wasn't compiling, it was creating errors. I fixed them. Node works, plotting works, farmer works, but farmer creates a problem. There was some small issues. One of them we have fixed with Nazar, and now I have to change some more things. The current problem is the solution is getting out of range, and that's why it's getting invalidated. After I solved it, I hope there won't be anything left to do. If so, I will fix them too. But I'm really feeling we are really close to finishing end-to-end plotting, like all the things together, node, farmer, plotting, everything. That's all on my side.
Awesome. Do you want to walk us through the latest commits since the last meeting?
Sure. Let's share the screen. Is it K, my screen?
Yeah.
Okay, great. Okay, let's go over the commits. So I did a rebase, that's why dates are changed, but these are basically the things. So this is the new plotting code. The difference from the previous code was iterating over encodings and doing parallel encoding on CPU. But for GPU, we cannot do that. We cannot iterate over encodings. We have to send these chunks of encodings to the GPU. So that's why a code is changed a bit. It's sending pieces of pieces now. It's like a 2D array. Other than that, I had some issues related to Rust, like I didn't know chunks exit. I was using chunks, and that's why I wasn't able to plot it successfully. It was creating some errors for safety, but we were able to fix it with Nazar.
It's actually not that. Chunks exact will just refuse to create chunks which are smaller than piece size if you have incorrect encoded piece length. It shouldn't affect anything if you have the correct size.
So this was the actual fix then?
Yeah.
Okay. Great to know. Other than that, I had to change some stuff in verification as well, since the API is a bit changed. This now has to be mutable. Maybe we can find a workaround. Nazar said this is right now not preferable, but we can leave as it is. Since I didn't know WASM, and WASM do not have stdlib.h in it, this was not optional, and it was not included in std. This new library, new dependency, was included in SP consensus Spartan without optional being true or without included in std, and that's why it was creating stdlib.h not found when I was trying to compile Node, but it didn't make sense to me since stdlib.h is present for sure. It was compiling and running successfully when I tried to plot. That was the fix. Other than that, I think there is nothing important in here. Yeah, small changes as well. It was better to declare this as piece. That's why it's a typo. This was not necessary, so I raised it. This was creating a warning for not being used. The only case is for tests, so I added this to not get a warning.
What was that?
Yeah. Yeah, there is this function in Spartan.rs is valid, and this is only being used for how to say, tests located in Spartan.rs, and it was creating a warning.
Which warning? It's public function.
Sorry.
So this is super strange. If you have it configured to just test, this is like super strange. You should probably either remove it or something, or at least make it like pub create. It's strange to have public and configured to test. It doesn't make any sense together.
Yeah, you're right. You're right. Okay, I will check that. Other than that, I didn't want to use piece and prime size bytes redeclared again, since these were declared in here. So I declared this dependency and added the cargo toml and removed these redeclarations. Use this instead. That's all. And now I'm trying to fix the node site for verification. After that, this should be finished and merged to main. Any questions? Should I stop sharing that?
Is that everything you've done in the last week, Ozgun? Or is that just the commits since the last PR that was approved?
It was just the commits. I spent most of my time configuring how to resolve the compilation errors and figuring out that these were related to this STD stuff. Took a lot of time for me. That's why code-wise it's not that big for this week, but I spent a lot of efforts in here.
Okay. Can you share the open PRs that you're working on right now, or are there any?
No, after finishing verification, then I will open a PR. There was a draft PR. Nazar gave some insights on that. And since every time I commit to it, there's some emails going for you, like you two are subscribed to all PRs. I canceled it, and after everything is working, I will create a brand new PR.
Okay. So what do you have left to do before you can submit that PR, and how long do you think that will take you?
Right now, verification is not working since it says out of solution range. I couldn't figure out exactly why. I assumed it was due to size of the arrays, but Nazar explained me why is why that is not the case. So next step, I should figure out what's wrong, and then I should fix it. If there is nothing more, no new bugs coming, it should be done, and I can submit a PR as soon as tomorrow or some sooner maybe. But if some new bugs came along, I don't know.
I think we need to push it and try to fix it today. So maybe we can have a call after this meeting. Try
Okay,
to squash
great.
all the bugs that remain.
Okay, is this what you were talking about? Is blocking you on doing the subspace upgrade, Nazar?
Yes, this is.
Okay. Yeah, we got it. This is a huge priority, Ozgun. We got to try to get this merged in and fixed because it's currently blocking Nazar and kind of everything, the whole show right now.
Yeah, I know.
But I know you've
was
been
even
working hard on it.
today. Yeah.
Okay. Okay. Cool. Appreciate the
I'm
hard
trying
work.
my best. Okay.
Okay.
Is
Can you
it all
open up
like-
the?
Yeah.
Sorry.
Sorry, I didn't notice you were talking. Please continue.
Can you open up the board and show us what you're tracking right now?
Sure. Currently, I was not updating the board since every day there's so many chaotic things happening. Function protocol, not here, protocol engineering.
I think it was protocol board there.
There's two different boards.
Okay.
One is for the GPU and one is for the protocol.
So this is done actually. This is also done. The new
Sorry,
thing
when you say
is-
done, do you mean it's been submitted or it's been approved and merged in?
No. Okay, here's the progress for merge. Like, I didn't merge anything during the mid steps since verification was not working. So if I were to submit anything, it would break the ongoing system. That's why I'm waiting for everything to finish together as a whole, so that it will be a working thing.
Okay, can you add another column or maybe multiple columns into this board to show what is pending approval and what is pending merge so that we can know, like, because when I see completed, I assume that that's like 100% done. You know, there's no extra work, but it sounds like that there is still maybe some extra integration work on some of these tasks.
Okay, we'll do so.
Okay, awesome. So can you just moved some tickets and just said this is done. Can you just kind of say that one more time? Exactly what was done? Okay.
Code-wise, these are done. Like, these are working, these are implemented, but these are in a branch, and this branch is not submitted as a PR at the moment. That's what's being done.
Okay. So code-wise, it's done, but you still have bugs that you haven't resolved.
Okay, yeah. Integrate CUDA encoding to actual plotting. Actual plotting, yes, this is done 100% code-wise, but on the verification side, there are more things that I need to change, and this should be in the progress right now. I should edit, and after those are finished, I can submit all of these as a PR to main.
Okay, cool. Can you so let's add that as an in-progress task, verification. Okay. Are there any other in-progress tasks you have right now?
Actually, no. And after that, create and prepare. Yeah, that will be all.
Okay. And I think these are starting to get a little bit out of sync now between these different boards. So this is for sloth 256189, or this is for some other part of the mono repo?
This is all mixed up together. I didn't know
Okay.
I have to separate them.
Okay. Okay, that's fine. That's why I'm asking, just so we can get clarity here. So I think, so what makes sense to you? Should you keep tracking GPU specific code in this board and then protocol stuff in the other board, or should it all get merged into the other board?
I think separating protocol and GPU codes would be better, because this is getting like out of hands. So we can consider GPU side code is done, and now protocol side code is in work in progress. That should be more tidy, I believe.
So you want to keep tracking them separately, is what you're saying?
Yes, yes.
Okay.
It doesn't seem to me that what we are doing right now has anything to do with GPU anymore. It's just farmer and just a client. So the GPU work as such was already done when we released the crate.
Yes, exactly. So these are not actually GPU plotter anymore.
Okay, so let's track these issues that you're currently working on. Let's just migrate those over to the protocol board, so we can kind of keep all this in one place.
Okay. Great.
Okay. And then maybe we can stop. I know you've got a bunch of other stuff on here, so so once you have the verification working, then full end-to-end tests should be working as well.
Yes, that's true.
Okay. Okay. And what are you planning to work on after that is done?
We were talking about writing that article. Other than that, nothing came to my mind. I can prepare for Substrate, like watching some videos or Substrate Academy, as you mentioned. These can be the new tracks. I don't know. Do you have suggestions?
Nazar, do you have anything that you can offload to Ozgun on the farmer side that can speed things up?
I'm afraid I'll have to like turn everything upside down for a little while. But if there is something that is like distinct, I will probably create a ticket and then discuss.
Okay. We had talked about re-exposing the farmer as a lib so that it could be used by the desktop application. Are we ready to do that yet, or do we need to wait for you to turn things upside down and right side up again?
I think that actually can be done somewhat in parallel, depending on how that is done exactly, but I think it should be possible.
Okay. Do you think you can create a ticket for Ozgun that kind of explains what you're thinking there?
Yes.
Okay. So just to give some background to Ozgun, so perhaps you're aware that farmer is a binary and not a lib right now. And we'd like to turn it into a lib so that we could, if we had like a CLI, that the CLI could basically just, call the lib. If we have a desktop application like Tori that has a Rust backend, it can just call the lib and it can just instantiate sort of farmers on demand, and maybe even multiple farmers for multiple plots, for example. So that's not really that's not a task of like adding any new functionality. It's just refactoring the library. So we thought that would be a good way for you to gain a better understanding of the entire farmer protocol, is by refactoring it so that it's exposed as a library instead.
Well, I think that's a great idea, yeah.
And this is actually a really critical task because it's kind of blocking the desktop farmer, and it's going to make a lot of other upgrades we're trying to do to the protocol, I think, easier from an architecture point of view if we have it done that way.
I see.
Okay. So yeah, so that, I think that would be the next priority after you finish the end-to-end tests for the GPU.
All right.
And we'll track that on the protocol board. There's our create a ticket there. Okay.
Okay.
Great. All
Should I stop
right.
sharing?
Any
Or
questions?
any more questions?
Let's see if there's any questions. Any other questions, comments from the group for Ozgun on the GPU project or the plotting library? Okay, great. All right, thanks for the update, Ozgun.
No problem.
Okay, Nazar, take it away.
Okay, let me share the screen. Is it visible?
Yep.
Awesome. So this is where we left off. We basically had post-processing of blocks and a way to produce pieces with notifications to the farmer. And this is where we will go from. So the second pull request was, let's see, it was some fixes to the witness, and there was a witness abstraction created such that we can verify that later, because there was no verification up to this point. And
sorry,
okay.
to interrupt, Nazar. Does everybody know what the term witness means cryptographically?
I do.
Serge?
Yeah, I saw it a couple of times in our protocol description.
Okay. Yeah, it just means a Merkle proof. That's all. It's just the jargon for Merkle proof. One instance of a Merkle proof.
Okay, so I'll not go through every line. I will just show you the bigger idea of what was happening. So yes, so we have the block importing pipeline, and in that pipeline we are sending notifications with the block number. So this is what the notification we had before, just number for a particular block. This is like a generic in Rust that allows you to extract the thing. But what we want to do, we want to actually block the block production pipeline until, or like block import pipeline, until we have actually the result of archiving process. Because at that point, we need to either insert some transactions into transaction pool or we don't. And we don't really want block importing to go further, because that might mean that we will not have information about some of the extrinsics which need to be put into the blockchain before they actually are in the blockchain. So what's happening there, when we have the result of the import of the block, this is where we've been before. There was a to-do to wait for archived segments and insert extrinsic. So this is basically it. We have a channel. We send a sender of that channel together with block number instead of just block number over to archiver, and then we wait on the receiver side here for some root blocks, and if there are any, then we will store them into the LRU cache. This LRU cache was added to the what is this? Block import in this case, and this is where we will go every time we want to import a block to check what are the extrinsic that we expect to be there, and then we'll verify against the actual block whether they're actually there. And on the archiver side, this is just constant move around. We receive the block number and sender, and every time we have archived segment, we will take a root block from it and we will send it using sender back to block import pipeline. So basically, block import pipeline will be blocked here until we get root blocks, if there are any. And there is a to-do to actually insert extrinsic into the blockchain, which is not implemented in this pull request, but this is it. And on the Merkle tree side, there was actually a refactoring. So we were using the proof data structure, which was basically the same as in the library that we are using. But instead, you've created a witness. It basically has some bytes. Copy and write data structure allows you to have either owned or referenced value. So we can use both ways. We can work with both vectors and slices if you need to. We can construct it using these bytes. There will be some verification whether it's of a reasonable size. And then we can either validate whether that witness actually is correct. So for that, we need to know the root of the Merkle tree. We need to know the index of a piece within the segment, and we need to know the hash of the leaf that it corresponds to, because the witness doesn't really contain hashes or the root or the data itself. It's just like the middle part of it. So because library expects actually the proof, we take the data and we reconstruct the proof data structure from the library, and then we can call validate method on it to actually get the result. And it's either true or false. And there is also a convenience method that takes the whole piece. It will slice the record from it, or it will slice the witness from it. It will slice the record from it. It will hash the record, and then it will try to validate in the right place, which is very convenient when we get something from the network. So this is just an abstraction. It's slightly incorrect. It will be fixed in later pull requests, but it's a useful concept that is domain specific for our protocol. And the get proof was removed and replaced with get witness completely. So this is the second pull request. Feel free to interrupt me at any point if you don't understand something. Any questions so far? Cool, let's move on. So the third upgrade was we've actually added those extrinsics, which will go into the blockchain. So we will have some archiving process running. We will have root blocks, and then those root blocks will get into the blockchain history. So they are persisted. And there will be also a hash map inside of it, inside of runtime, that will have a mapping from the segment index to the Merkle tree root for verification. So this is not important. This is not important. Yes, this is just, I think, moved around a little bit. And yes, so we have a wait for trait, which has like a function placeholders for different weights for different extrinsics. We have the map from the segment index to the Merkle tree root. And what is this? Yeah, there was quite a bit of refactoring. Let me probably go through the commits. This is why it's useful. Unused extrinsic, it's really unused. This is just the comments. I moved root block from the archiver, I believe, where it was before in C consensus POC, to the more common data structure, more common crate, which is called, where is it? Okay, it's still in SP consensus partner. So basically, the idea is that this root block will have to be usable in many contexts. What's happening?
Serge dropped off. He just joined again.
So it needs to be usable in runtime. It needs to be usable in non-runtime. So we need to move it somewhere that is noisily compatible. And SP is the set of crates where that can compile to noisily. And this is basically why we have it here, but it will be moved in the other crate later on. Then I've added extrinsic itself. So we have some refactoring related to that. Basically, we only had one unsigned extrinsic before. And now we have extrinsic for equivocation report. And we also have extrinsic for the root block. So I had to change a few things. For instance, when we have, this is just renaming. Here, when we had validate unsigned, we were basically calling the same named method, which was alone. And now we have validate equivocation report, and we have validate root block. The equivocation side was just renaming. Nothing has changed there. But on the root block side, we basically check that this is either local transaction, so we've created it, or it's during the block import. So we do not allow those transactions to be broadcasted to the network. It's only intended to be local. And when we add it, we actually have longevity 1. It will be 0 in the next pull request, so that it will not last longer than one block. So we will, when we archive something at block X, we will include this transaction right in the block X+1, not X+2 or further. So it is deterministic on every node in the network, and we can always verify that exactly. There is also this reusable.
Nazar, just want to pause for a second. This is kind of a complicated thing to understand. Does that make sense to you guys? Like that we have a transaction that is not getting gossiped, but it's still getting included in the blockchain and it's still secure, even though it's not signed?
No.
Okay, so
it's not secure because of that. I will show you why it's secure.
Well, I mean, we'll get to the implementation side of it, but I guess the point is that we have some, like, there's this thing called an unsigned extrinsic, which basically whoever produced, like all nodes produce the extrinsic, whether it's an equivocation report, which means somebody did something bad, or in this case there's a root block which everybody should arrive at the same time as the transactions come in. Everybody should, it's deterministic as to how these things are created, but we don't need to gossip them because everybody creates them automatically. So how do we include it in the blockchain? Well, whoever produces the next block will take it out of their transaction pool, and it will be like the first transaction, the first extrinsic in the new block. And then everybody else should have created it locally, and then whenever they receive it, they say, "Okay, I'm expecting this to be in the block, and here's my local version. It matches, so everything's good." And if it wasn't in there, then that would be a problem. Like that would be an invalid block. And if it was different, that would be an invalid block. So this is kind of what's occurring. This is a pattern which we pulled from Parity that they're using for equivocation reports. We realized we could do the same thing for these for this root block, which you might be wondering, well, why do we need to commit the root block to the blockchain? Because like we can just derive it deterministically, right? And just make it like a runtime transition. And the reason for this is because light clients need to be able to sync the root chain. Basically, farmers are going to become light clients eventually. They need to be able to sync the root chain. And in order to do this, they have to have a trusted source of what is the root chain. And the only thing that they can trust is the blockchain itself. So we're basically committing it to the blockchain so that then we can sync this without having to sync the entire blockchain. So this is something which we haven't implemented yet, which is like a little bit further down on the roadmap, but eventually farmers are not going to sync the entire blockchain history. They're just going to sync these root blocks, and they're going to apply this to the runtime. They're going to get the right verification parameters so now that they can verify blocks, but they don't have to sync the whole chain, because eventually the chain will be like petabytes or exabytes of history, and it's inconceivable that every farmer, even any farmer, could sync that. So we're building in the architecture here, the ability to make this scale, basically. Does that make more sense, Ozgun?
A lot more, thank you.
Yeah, and this like unsigned extrinsics, they can be also implicitly assumed to be signed by the block creator. So whoever creates a block, they sign the whole block, and they kind of sign these transactions within it, even though they are unsigned. And propagate false allows them to be just local in transaction pool and not broadcasted. The transaction purity is max for this transaction because it is critical for these root blocks to be included into every block as soon as possible. Otherwise, it breaks the protocol. And that was actually the reason for the other change I will show you a bit later. As to validation, this is actually incorrect. I removed it later. There is a to-do to check it. But basically, the only validation for that is that we do not yet have any mapping for that segment index. This is the only thing we can reasonably verify within the runtime itself. So this is like the hash map from segment index to the root block. In tests, I think this is just a renaming. This is not imported as well. Merkle tree, yeah. There is one important thing in the equivocation. Don't see where it is. Okay, it's probably in the next commit after this. So this was, yeah. Then I renamed a few things. Yeah, Runtime API. So we need to be able to submit that extrinsic to the network, and that is usually done with the so-called Runtime API. So basically, we have this SP consensus POC crate, which is noisily compatible, and it has a trait that is POC API. There is actually another trait called POC API in a different crate, which is confusing, but what we have is what we have. And there are a few methods that the runtime needs to implement. So we basically define abstractly that there should be submit store root block extrinsic method, which will take root block and will submit it to the runtime. It doesn't really describe how. And then when we go to Substrate runtime, this is test runtime. We can go to the actual runtime. We have this like a method implemented here, which will go to our particular implementation, which in our case is palette POC, palette Spartan, which is called POC here, and there will be a method there. And then we go to our palette, and here we will see the same method. Submit store root block, and here we have a root block, and then we create an extrinsic, and then we try to submit it, and then we'll go through all the verification that you'll either fail or not fail. And this is like a mock for the test environment, which is why I was talking on a different call that when we use this in tests, we do not actually have a transaction. We just fill the map, which actually prevents block from being verified in the tests. And there is an important fix in the equivocation, I believe, here. Maybe not here, but should be here. No, it's just in renaming. Okay. Then we go to a C consensus POC. We need to actually make use of that thing. So a few variables were named, but basically what happens is every time we receive a root block, we take a log from the from that LRU cache. We go and get the like index for the block number that corresponds to the block number after current one. This is why we have block number +1. 1 is a generic thing because block number is not defined as a specific type in this context. It's just a number for block, as you remember. And we just push root block into their list. So we say that at this block height, there should be this kind of list of root blocks present. And then when we receive a new root block, we will actually go to Runtime API, and we call this method we've just created. And we will say that at the current height of the current block, we will submit this extrinsic, and it will be included into the next actual block in its contents. And after that, there was a check of some sort. Yeah, so this is like a sanity check for archiver, I believe. We have this variable which will store the latest archived block. This is because we can have a fork in the network, and we can potentially switch from one branch to the other. And if both branches are on the same height, like let's say we went through the fork like 3 blocks forward, and then we basically go 3 blocks back and then apply 3 blocks from the other branch, we will go through blocks at the height that we've already processed. And we will send those blocks, like blocks at that height minus k depth, to the archiving process, but archiving process already went through those old blocks. So we just check here that we do not go through the same block twice, because they will be deterministic at the sufficient depth. So this is just a sanity check so that archiver doesn't produce incorrect history. And if we have block that we've already seen, that we just skip. And this is the third upgrade. I think we went quicker than previously. How much time do we have? It's like half an hour.
We're doing great. We're doing great on time. We got like almost an hour. So yeah, awesome. You're doing good job.
So yeah, this is the third part. Let's go to the fourth. Okay, there was upgrade to substrate upgrade. I will not go over that. I think fourth upgrade. So then we need to actually validate that those extrinsics are there, they make sense, they are exactly the same as we expect. And there is a comment that I'm not proud of it, but it was fixed later, thankfully. So yes, I checked this case whether it should be 0 or 1. It should be actually 0. So we include it in the very next block. At some point should be fixed to equivocation. No, it's not here. Okay. So these are just refactoring of some sort. And here we just derive a hash. So we can use it in a hash set or hash map. And then the meat of the logic is in a CE consensus POC, because we cannot implement this functionality, at least not yet, in the runtime, unfortunately. This is one of the problems that prevent us from becoming a really a parachain at the moment. So root blocks that we get should have non-zero number of root blocks for a particular block, if they should be included. So what we do, we basically go through the, we look into the root blocks LRU cache. We want to just look into it. We don't necessarily want to update the recency of the particular element. So like when we go forward, we want to keep in LRU cache the newer blocks, but we don't want to forget about the older ones. That's why we have a capacity for it. And peek will allow you to just look into it, but not update the counter that this is like was checked recently. So basically we go through, we look into the particular item, and then we try to come up with the hash set of all of the root blocks that are at that height. If there are any, then we need to go into our block. We need to read its body that contains extrinsics. And for every extrinsic, we basically need to try to decode it. And if you find an extrinsic, which is the extrinsic that we are looking for, which is stored block, then we will remove that particular extrinsic from our hash set. And hopefully by the end of this process, we need to have an empty hash set. Otherwise, we have something which is not present in the block, but it should have been. Similarly, when we remove something from the hash set, but it wasn't in the hash set, then someone included root block that shouldn't be included. So this is an error itself as well. And in both cases, we will actually prevent the block from being imported because it's invalid. It's in client import error. So this is the primary.
Sorry, Nazar, actually, I'm confused on something now.
Okay.
So what you just explained, that's the process when a block comes through and it has a root block in its extrinsic set, and we need to filter that out.
We need to check.
And then you said we take it out of the extrinsic set, so we don't actually process it in the runtime?
No, this is just a convenience. So we create a local hash set. This is like a local state, things that need to be there.
This is just in the client?
Yes, it's just a temporary variable. So every time we meet something that is here, we just remove it from there. So by the end of the process, we need to remove everything, but we also shouldn't remove something that's not there. It's just a local variable to keep track of what was checked. We could have similarly create like another hash set and then compare that both hash sets are exactly the same, but then we need to do allocations, which is not nice. So this is kind of more efficient way to do it.
So this is some of the logic that you're saying it would be more convenient to have within the runtime so that we could upgrade it.
Absolutely.
Okay.
This is like some of it. Yeah.
Mm-hmm.
And actually the next upgrade was after this. Okay, let me skip the fifth one. This is actually the upgrade that cleans that up a little bit. So what I did, I added yet another runtime API, which is called extract root block. It will basically take any extrinsic whatsoever, and it will try to interpret it as an extrinsic for the root block. And if it is root block and if it's valid, then it will return the root block itself. So it doesn't return the extrinsic, we just return the data we care about, which hopefully will not change as often as everything else. So it's kind of opaque how it works internally. And then in the node runtime, what we have this method, this function. I basically made it a separate, only because this is within impl runtime API's macro, which basically means no autocomplete, no nothing whatsoever. So it's much easier to write code where you can actually check what you're writing, and there is autocomplete. So this is why it's
I didn't get one thing. Like, In the previous function, isn't it calling itself endlessly?
No, this is not C++. You need to use
Yeah, but I still
self.extract
couldn't get
root block to call itself, so it's not. Yeah, if you expand it, it's actually implementation of a trait. It implements POC API for MSP consensus POC for the runtime that we have. It's a method. Yeah, so here we actually have all of the types necessary because this is like the final runtime we are assembling from different pieces. And that's why we can actually check, we can try to decode this as unchecked extrinsic, and then we can try to figure out what kind of function, which is basically a call that's inside of that extrinsic. And if that extrinsic corresponds to our crate, and the call that we care about, we have root block, we can return it, otherwise we can't. Otherwise, it means that either extrinsic is incorrect or it's not the extrinsic we care about. Either way, it's not. So this is how we actually extract those things. And in here, instead of all of this mess, which I basically try to mimic the data structures and indexes that correspond to what is happening in runtime effectively, we can just do the runtime call. We can say, try to decode extrinsic with the runtime implementation as of this block. So that actually decoding, it's upgradable because it's part of the runtime. And then the logic is basically the same. We can just do matching and checking and clean up the hash set accordingly.
Hey, Nazar, let's just pause here for a second. There's something really important I want to make sure everybody understands of, like you had mentioned something earlier, Nazar, you said this is why we can't, part of the reason why we can't be a parachain. And I just want to make sure everybody really understands, like in the context of what we're discussing right now, the difference between the substrate client and the substrate runtime, and why we need to be a parachain. We need everything to occur within the runtime for the relay chain to work correctly, why we can't do that, and why we have, and there's certain things that we have to have in the client, but even if we're not a parachain, it's still nice to have things in the runtime because then we have forkless runtime upgrades. So basically we can soft fork with governance as opposed to having a hard fork, which we can do with the client, which we have to do if we want to change anything in the client. That's like a different implementation of the protocol versus a different implementation of the runtime. So these are like, all of these things are interrelated, and it's really important to understand. So I just want to pause to make sure, like, if that doesn't make sense to you, please stop us right now, because we need to talk about this a little bit more.
So like runtime, it's upgraded atomically at specific height. So it is perfectly reasonable to assume that when we call this method at a specific height, and then we call it at a different height, the actual intrinsic internally can be different. But because we made the API such that we just care about root block, as soon as there is a root block there, we'll be able to decode it. The implementation of this function in runtime, it can actually be different by that time. But we only care about external API, and that's the nice thing about Runtime API. We can expose like purpose-built methods without exposing all the internals of it. Because until we assemble the runtime from multiple pieces, this client has no idea to know, like, it has no way to know what the actual like set of extrinsics and palettes and everything looks like. And that is necessary to use these like indexes correctly. So we just, by having Runtime API, we avoid all that. And this will be upgradable. So like if you add another palette, it can like shift the set of palettes or extrinsics that we have.
Did you have a question, Ozgun?
Yeah, it doesn't make much sense to me. I couldn't follow.
Okay. Okay, so when we archive the history, we produce root blocks. So we have like a piece of history with the size of the segment, and we create root block out of it eventually, right? Lucy.
And a root block is just a commitment to some period of history. It's kind of like a block header is a commitment to a block, right? That's kind of, you can think of it as like a block header over many, many blocks.
Yeah.
Yeah. Let it load, archiving. Okay. So the root block is root block here. So like we built the Merkle tree, we like assembled. Root block is basically like a container which essentially holds everything within that segment. And we want to store it in the history, right? But the rules are that we want to store it in the history right in the next block after block at which we've produced this root block. So when we've been at the block N, we went K blocks into depth, took a block from there, added to the archive, and that resulted in a new segment created with according root block. Then at N+1, we should have that root block committed to the actual blockchain back. So in order for that to happen, we need to have this root blocks LRU cache, where we remember at which block which root blocks exactly should be stored, and we compare them against the actual extrinsics that are present in the block once we import it. So we don't import blocks which do not match our expectations.
Okay.
Okay, upgrade step 5. Basically, I got to the point where I needed to do some refactoring such that we can reuse this archiving process on the farmer, for instance. And we also have a bunch of those like constants and data types that really need to be generic. And we had a SP consensus Spartan crate before, but it was for Spartan and it didn't have really great structure. So basically, I decided to create 2 crates. It's all about moving things around. We can probably go through commits as well. So yeah, this is just replaced some of the dependencies with dependency on Subspace archiving. And then we have a new crate, Subspace archiving. That crate has just 2 modules. One is archiver, the other one is Merkle tree, just like before. There were some slight changes here, I believe. Yeah, and the witness was updated because it wasn't correct, actually. And then yeah, there was just 2 modules in here for now. So this is just moving things out of a C consensus POC, so it's reusable. Then there was another create subspace core primitives where root block was moved into, and that is no STD compatible. So again, lots of refactoring all over the place where it was used. Even Farmer depends on it now because we had pieces and piece size there. But basically, we have this crate, which has a bunch of dependencies, all of which are no STD compatible. And then even runtime depends on it, basically. So this is another refactoring, another crate. Then I have been working on tests for Merkle tree. As it often happens, there were some bugs, and those bugs were fixed, and there were tests added to make sure it works correctly. And then I was working on tests for archiver and also had some fixes. I have added some instantiation errors because previously we were just panicking here. But I thought it might be more useful to have like more reasonable errors since it's a library and not part of the SC consensus POC, so the users may not read documentation and may call it with some stupid values. So there is actually a bunch of tests that verify those stupid behaviors as well. Not in this commit, unfortunately. Useful derives. Yeah, test for invalid usage. So every scenario that is not expected to work at all, it will basically be tested here. So it's important to have tests not only for correct usage, but also incorrect usage. So every single case that we foresee is implemented, and I removed some of the extra license files because we had MIT plus Apache, but I think we're using Apache right now, so I just removed MIT. So this is just a refactoring for the most part, but now we have two reusable crates. Step 6. Yes, so the idea is that we actually need to be able to restart the node. So imagine we've archived up to some block, and then we shut our node down, and then we want to start later, and we want to like catch up from that point onwards. We need to actually remember what we've archived. So the first step for that was to go to the core primitives and add last archived block field to our root block. And that contains the number of the block that was archived, and it also contains how many bytes we've archived. So if it's none, then we've archived the whole block, which is useful to know. Otherwise, it is how many bytes we've archived, so we can like continue from there onwards. And then there is a bunch of logic inside of the archiver that checks, what is this? Are these tests? Yes, these are tests. There are a few checks for the cases where we have initialization with some initial state. So basically, we can create an archiver from scratch when we specify record size and segment size, and we can fill it with blocks. But we can also initialize it with record size, segment size, and the last root block, and the block contents of the last block that was at least partially archived. And if that is the case, we can actually go and code that block. We can fill all of the internal variables of the archiver itself using information from the root block. We can push that root block into the buffer, and we can slice the beginning of that buffer up until point of the number of archived bytes. So we have last root block with, like, let's say 10 bytes archived. So we'll remove the first 10 bytes. We'll convert the rest into the continuation segment, and we can move from there as if you were not even restarting at all. And there are a few, again, checks whether the number of archived bytes actually makes sense. And there is an implementation here. What is this? Produce segment, which actually internally keeps track of last archived block. So it will keep track of the number of the block that was archived and how many bytes were archived. And there is also some, it is much better to look at the commits because there is some shifting of the code here. But there is basically a similar tracking in here for how many bytes were archived. So this was, I'm not sure it was used. Yes, it was. So in the SC consensus POC, we now have this like primitive on the archiver side that we can use to continue from some point. So for that, what we do, we actually check whether there was some last archived, last root block in the history. For that, we start with the genesis block. We start with the latest block, and we go down towards the genesis block. For every block, we just extract it, look at the extrinsics. When we find an extrinsic, which is the root block extrinsic, then we check if this is the newest one. If it's this newest one, we store it. Otherwise, we skip. If there was none before, we also store it. And then eventually we will have some or none. And that means we have a root block. And when we have a root block, we can actually go and create an archiver with some state. If you don't have root block yet, so we just went all the way to Genesis and there was still no root block archived, then we just too early. So in that case, we will need to initialize archiver just as usual.
A quick question, Nazar. What's the overhead right now for the number of like root block, like full root blocks or root block headers that we're storing somewhere? like outside of the runtime storage?
I don't think I understand the question.
Like you've got some of these data structures here, which it's not clear if they're like for instance, you've got like the last root block hash and like root block number, and this was in some other code as well that you'd gone over previously. But it seems like you're tracking some like metadata or like mappings for the root blocks, and I'm just wondering, is this like all the way back from Genesis that you're tracking everything, or is this just like for the last like K root blocks or something like that?
Okay, so this is actually not a new information. This comes from the blockchain itself. So we just go to the client and extract blocks, starting from the newest one.
Okay.
So we extract this latest root block information from actual extrinsics of actual blocks of the history. It's not an additional information on top.
Okay,
but we
so
assume that there will be like maybe 100, maybe 200 blocks worth of data to actually find the root block. So it's reasonable that you can go through 100 blocks once during the node startup to find this latest root block and continue from there. It's not too expensive.
Okay, so it assumes an archival node or an archival client to begin with, or a client that stores the full history. But realistically, it only assumes for the last like 256 blocks that are needed if it has to restart.
Yeah.
If there was so if the node went offline and then it came back online, well, I guess it wouldn't matter if it was a long.
Restart the state up to this point, and then everything else will go through the block import pipeline anyway.
Okay. So it'll have to sync up to whatever it's missing in the meantime, regardless. Yeah. Got it. Yeah. Okay. Thanks. So the short answer is there's not any additional overhead, basically.
No.
Okay.
So this was the gist of what was happening here. There are some required updates here and there, but it's not critical to understanding of it. Any questions there? This is the recent one that I explained today. Basically, we have a new event about root block stored. We deposit it every time we process the extrinsic when we have a call. Then what is this? Create root block. This is for mock. This is for tests. Okay. We should have a bunch of tests there. What is changed? Yeah, these are the tests that are commented out. They should theoretically work, but because transactions are not processed, they don't. In the archiver, this is to do. Yeah, so I also moved we had this piece of logic, which was this doesn't look nice. Okay, let me go through commits. It would make much more sense. So this is about events. It's not interesting. Tests, to-dos, a check, also tests. Yeah. So this will make much more sense. So basically, we had a thing at the left. There was this spawn blocking call, which was running the background feature within the import queue function. And I was doing some changes, and for those changes to look nicer, it made sense to actually move some of that logic internally to the separate function. So we've created a separate function called start subspace archiver, which basically contained just that background process within it. And it had slightly reduced requirements to the client in terms of APIs it should provide. And we're just calling that function from here now. No, not here. We are calling that from the service in the actual node implementation. This is just decoupling. Instead of calling one function, we are calling two functions now. Because they're kind of separate, and this thing I cannot run in tests. At least I don't think so. At least not yet. But this I can run. So this is why I needed to refactor it. And yeah. Then this was required to do.
Just a quick question. So I saw, so we have an event now that a root block has been archived.
Yes.
That I guess we could read like in some front end app or from
Yes.
some client. Do you know if we have events like consistently for other like consensus related things like epoch change, error change, like things like that?
We don't have for error change and epoch change. We have for equivocation.
Okay. I added a task to the board. I think we should probably just review the spec and see.
Those are actually probably not necessary because we track those values in the consensus logs. That's how our front-end template already figures out when the difficulty changes.
Okay.
So I'm not sure we need events, but we can probably add them. I don't know.
Okay, just something we can think about in the future. We might need to just do a review and see if there's any other events we should include, since it's fairly easy to do.
Exactly. So yeah, basically start subspace archiver was the function that was decoupled. That was why I had to do it, but the test eventually didn't work. So it's added, but it's commented out. And yeah, that's basically it for the silence one. The 8th one is, yeah, object and block archiver. So this is archiving of pre-Genesis history, essentially. So let's
just pause here for a second, Nazar, and I'll just maybe just to orient people and give you a break. This is something that is really critical to understand about our protocol, is like this chicken and egg problem that we have, where we can't run consensus based on the history if we don't have history. So we can't generate a Genesis block or like a first proof if we don't have some history. And so the way that we've handled this in the past was just with some like deterministic data, you know, or like random, like apparently random data generated from like a seed for some minimum initial state. But the way that this is realistically going to work, the way that we're planning to launch this when we go live with mainnet or even with our next testnet, is going to be to have some seed data, some history, some useful history or useful data that we want to seed the blockchain with. And this should be a lot of space. It should be like at least a terabyte, maybe like 10 terabytes of data. The reason that we need to do this is because if you want to run a farmer, you want to use up all your disk space, right? And so we have some assumption of what the minimum disk space is, or the average, like maybe it's 100 gigabytes or maybe it's a terabyte. Well, if the average farmer has a 1 terabyte plot and we start with a 1 gigabyte history, then that means that for it to be useful from the point of view of the farmer, then they have to create 1,000 plots, right? And then they have to update those 1,000 plots every time there's a new block. So this is conceivable, but it's very inefficient. And it's also very hard to implement this efficiently as well, like to write the code such that this works like in a nice way. And so that's kind of why we would like the history, the Genesis history, to be at least as big, if not larger, than the average plot size. And also it kind of, this like ties full circle back into what we're doing with relaying and archiving blocks from other chains. Like, you know, back to the relayer app, Serge, like you've said, like, how do we store data? You know, how do we sync up to the current state of these parachains so that we make sure we've got everything? Well, this is the solution to that. So basically, before the network launches, or before you start the node, it's got some data set, which is sort of like a Genesis data set, which gets uploaded into the blockchain and is still retrievable from like the object API, like the storage API that we have. So that's kind of, that's like a big thing that like Nazar and I have been talking about for a long time and is really critical. for like for the usability of the protocol and like to fit in with our notion of like backing up blockchains. And this is the thing that actually provides for that. So this is like another important thing that you just need to understand, like conceptually, even if you don't understand how the code works, like you need to understand this about the protocol, like why it has to be this way or why it's really bad if it's not this way. Does that make sense to you guys? Are there any questions on that? Okay.
Okay, back to implementation. I was doing this thing where the number of bytes that were archived was always non-zero, which stopped being true when we have the objects before the history. Why? Is because when we have some objects before the history, then we still need to store some last archived block, and I didn't want to make it optional. So basically what we are saying that initially we have archived 0 bytes of block 0. And suddenly our number of bytes becomes it can't be non-zero. It needs to be 0 in this case. Previously it was 1, but it was only 1 because it was not used anywhere. It wasn't possible to have the very first block such that we can only archive 1 byte of the very first block. So this is why. This is the whole pull request, just changing non-zero to regular U32. Then, as we have this pre-Genesis history, we need to store it somehow. And it's not blocks, it's just some objects. So there are new segment items. We had blocks, block start, continuation, and root block before. Now we have objects, object start, and object continuation. Because this is not yet in production anywhere, I just put them in the order which corresponds to the order they will be included in the actual history. So we'll start with objects, then we'll continue with the rest. This is the case where we are tracking the number of bytes of the archived block. Of course, for segments, we don't care about archived blocks. So this doesn't actually support restarting when not all objects were archived, but we assume that everyone has access to all of the objects for now. And then in here, where we track what segments are archived and how much, we add support for objects, which is basically copy-paste for the most part of the block handling, with the exception that we don't track how many blocks and how many bytes in those blocks we archived. And we have, this is just like new naming of the variables. And that's it. So we just have objects support, but it's not used anywhere. The next step was to actually split archiver. We only had one archiver before, which was doing blocks, but we now kind of have 2 stages to the archiver. We first work with objects, and we cannot interleave objects and blocks, and then we do exclusively just blocks and no objects. So what I ended up doing is I've created the generic parameter for the archiver, and there is a trait which has 2 structs implementing it, object archiver state and block archiver state. The idea of this construction in Rust, if you're not familiar, is that in order to expose something as a public struct, if you have generic parameters, they should also be public. But I don't really want anyone to implement other kinds of archiver. So what I do is I create a private module that has public trait. So this can still be in the public API, you just cannot call it explicitly because you cannot import this. So the only way to access different versions of the archiver is actually to use these type aliases, because these types are public, but they are also not reachable for you through the private module. So you can only call this or this. You cannot create a third archiver outside of this crate. Okay, this is like an interesting, tricky construction in Rust. And the idea for that is that we will have a generic implementation, so you can create either block or object archiver initially. But if you are restarting with initial state, you can only do that for the object archiver. For the block archiver. because we only have initial state for blocks. We do not support restarts for objects, at least not yet. And for objects, we have add object method, and we can convert it into block archiver once we've archived all of the objects. And in block archiver, we can only add blocks. So we basically split our public API of the archiver into like two sets of methods. This is back to the argument that I like to repeat about misuse-resistant APIs, where you can design an API such that it is impossible to use incorrectly. So the block archiver, it's like non-clonable. You can only move into this function to get the block archiver. So object archiver is gone. They don't share any state. So yeah, this is how we can define an API to use properly. There are a bunch of tests for all this, and on the SC consensus POC, no, let me show you something different. Something different. Subspace core primitives. I had to derive Serge here because it's sent through the RPC. Root blocks are sent through RPC in addition to just, or instead of just segment indexes. And where is it? Yeah, I guess it's not used yet. Yeah, probably not used yet. So this is just renaming for the RPC API on the SC consensus POC. So we have this split, but it's like fully compatible with before, so it's not actually used yet. Then I've added a pre-genesis data generation method, which is very like simple and dumb. It just takes a seed and takes the size of the data you want, and it will basically hash the seed over and over and over again until it produces these many bytes. And of course, there are corresponding tests. Why that's useful? Because we can use that in a C consensus POC to create object archiver first. We can archive something that is derived from our blockchain seed, which in our case is just a subspace phrase. We will create number of bytes that corresponds to 10 segments of the history. We'll just fill our object archiver with that, and then we'll turn our object archiver into regular block archiver. So this is how we populate the pre-genesis data, but it's not included in transactions yet. That's why to do. And then, yeah, there was this big piece of logic that was searching for the last root block, and it was in a way. So I just moved that logic from here in line into a separate function. Nothing else has changed here. And then I made the changes I wanted to make, which is, yeah, so these root blocks had to be shared. And this basically piece of logic here was moved and slightly changed above the loop where we have the background archiving process. So all of this logic happens before archiving starts. And what we do here, we find the last root block as before. If it's fine, then we go through regular creation of block archiver. Otherwise, we start with an empty history. We we add the object, which is 10 times bigger than one segment. Supposedly, we get some root blocks with from segments. And then for every block, we will submit that as an extrinsic for the very first Genesis block. So all of this will be included into block number 1, not 0. Because as it turns out, there is actually a method exposed in Substrate which allows you to create, which allows you to modify basically or like create a Genesis block, which initially starts with just state root that contains like chain spec. We could have included our transactions there, but that would mean that we will have to rewrite a lot of stuff because the actual Genesis block creation is deep within dependencies. So we'll have to rework all of that all the way up from that tree, and I didn't want to do that. So I think the first block is acceptable here. And then
also be a huge block too.
Yeah. And I think this is also like a kind of to-do in my head. If we have this history big enough, might have so many root blocks that we cannot reasonably include that in one block. So we might have to split like 100 root blocks in block 1, 100 in blocks 2, and like 50 in blocks 3 if we need to. So this is like a temporary solution for this from seed, but theoretically we will have more implementations than just from seed here. We'll be able to take like, I don't know, a folder where we store all of the blocks of the Bitcoin. And we can start from that and like fill the history with Bitcoin. And because we need to verify all of this for the first block, and then we just share this data structure with root blocks through POC link. And we put at the block 1 all of the root blocks that we've accumulated. And then we turn into the block archiver. So this is similar to what it was, just we've filled this to do, basically.
That's an interesting point there, Nazar. I didn't realize that. So if we had like 10 terabytes of history,
yeah,
then that could be 20,000 root blocks, right?
Yes.
And there's another interesting problem. Like, well, if you do it piece by piece, like 1,000 at a time, then what if you get a solution from that you haven't included yet? Like, and how do you verify that?
That's also an interesting problem that I meant to talk with you about.
So I'm wondering if maybe we could have some notion of like,
That's why I like this idea, like with small seed, and then everything works as usual, so to speak.
Right. Yeah, I'm just wondering if we could have some initial state of the root of like that runtime storage contract. Do palettes support initial state? Is that
they do
for runtime
but
storage?
I think it's defined as a struct. So we probably wouldn't want to put like megabytes and megabytes in there. It will be a part of the runtime. We'll need to like upload it every time we want to upgrade things.
Yeah. Okay. Something to think about for sure.
Yeah.
I think that could be tricky to implement correctly.
Definitely. And I think this is what we've been looking for. Yeah. And this is the latest one. I basically added tests for all these mechanisms. And I think we've catched up till the very last one. This is where we are right now. We have progenesis history. We have a way to archive the actual history as we move forward with time. We just need to plot it and upgrade solution and prove and verify sites to actually use that actual history. So we are like very, very close to actually have Subspace instead of Spartan. And there will be a big pull request which will like go and rename POC and Spartan to Subspace in strategic places. It's kind of a mix right now. We have like Pilot Spartan, but inside we have POC and Spartan and Subspace. We'll do that before we have testnet. I know it's a lot. Any questions? We have about 10 minutes.
Awesome. Thanks for going through that, Nazar. I'm glad that we got caught up on that. I know that's like a lot of mental stuff to go through and a lot of mental stuff for you guys to follow along as well. I'm just curious if maybe each of you guys could just take like a minute and just like let us know, like, is this helpful? Is there additional stuff we can do? Do you feel like you understand? Like, just kind of give us some feedback on where you're at right now. Ozgun, if you want to go first.
The most useful part for that review for me is right now I know which part is where in the library, which is great. So if I were to work in some place, I know where to look. I got the big picture, which is also good. But for the implementation details, of course, it's not enough to review all the code like Nazar wrote it in maybe weeks or so, I don't know. For the implementation details, there are so many things that are unclear for me. But I believe the aim for this review is to get the big picture, and I think I got it. So I think it's very useful, as I said.
Awesome. Yeah, and you're right. It's to get the big picture and the conceptual. We're not expecting you to be able to jump in and just randomly work at any point in this code base, like instantaneously. But at least you've got a starting point if you need to figure something out. Okay, Serge, how about you?
Yeah, a lot of new stuff and a lot of complicated stuff. Well, yeah, I think it will need, I will need some time to digest what's going on, like on the theoretical side and this code base, like what's going on the practical side. So, yeah, quite difficult, but I think it will sink at some point.
Yeah, and I know you're, we didn't bring you on the team to be a back-end protocol engineer. So it's not, like Ozgun spent like 3 weeks, literally almost a month doing onboarding just on the theory behind the protocol and the conceptual side of the protocol. So we definitely don't expect you to be at the same level as the rest of us, but we do think it's really important, since you are, the next best substrate engineer that we have, on the runtime side, just to really understand how all this fits together and what this protocol is actually doing. Do you guys feel like this is something that we need to spend time going through at the offsite, like the theory or the conceptual side of the protocol, like up to where we're at right now in terms of the implementation?
If
It
you
would be
have the
nice,
time,
but
yeah,
go
sorry,
ahead.
please go on. No problem.
Yeah, it would be nice, but I'm not sure it will be like relevant for everyone in the team. So if we can split the team and discuss different things, like subgroups, to spend time more efficiently. But for me,
I don't think we
definitely,
have disjoint groups that can discuss it. Like me and Jeremiah probably need to be on both discussions, unfortunately.
yeah, true. Well, for me, it definitely would be useful.
Yeah, for me,
What
I
are you
was
gonna say?
Sorry. Also, it would be nice if we can do like some kind of like session, like pair programming, or maybe like more than pair. Like live coding session with Nazar.
At the offsite, or you mean just in between when he's working?
Well, I think offsite is just easier to get everyone's attention.
I don't have a laptop, so I'll be without computer most likely on the offsite.
Then I don't know, maybe online session. Just an idea.
Okay. I guess we could start having Nazar live stream on Twitch as he's working on Subspace, and start building his following that way. Okay, Ozgun, what else were you going to say?
Yeah, I was going to say, if we have the spare time for it, I think it will be very beneficial. But if you have other priorities, like this can be delayed or skipped for this weekly meetings. That was my idea.
Sorry, what could be skipped for the weekly meetings? Oh, you mean just to focus this in the weekly meetings versus at the offsite?
Yeah, exactly. Like if you have the extra time in the offsite, I think this will be very helpful to go over from start to the current position. But if we do not have the time in offsite, we can do it in the weekly meetings.
Yeah. Well, we definitely, so a lot of the offsite is going to be what is the next layer on top of this, right? That's extending everything that we've got right now. So if we don't understand what we've got right now, then it's not going to be a very productive discussion of how to build something on top of it. So, we right now we've got roughly 1 day out of the 4 allocated just to talking about the current implementation and design of everything that's been done on the protocol. But there's also going to be the expectation that you guys are going to do some review outside before we get into the offsite as well. But we can talk about that more at the next step sync. I wanted to cover that this morning, but the damn fire drill screwed everything up. Okay. Serge, I was hoping that we'd get a chance to talk about that one other PR that you're working on, the feature relayer. I guess just briefly, is there anything to talk about right now? Is there anything that's blocking you, or is there like a review, or can you just give us a quick update on where that's at?
You mean my open PR, parachains? Yeah, I mentioned on the previous meeting there are some problems. Yeah, we can talk about this. So let me open my notes. Yeah, so remember there was an issue with parablock binary. It was sending like the wrong hex. So the problem was that I was trying. So we're fetching blocks from RPC using HTTP, and it returns JSON. JSON has like block header and extrinsics. If I send, and then I get this JSON file and I try to convert it into like a signed block instance. And this signed block instance has a method like toHex. So it converts it to this string we eventually send to the subspace. So the problem is that in order to convert this JSON to signed block type instance, I need to decode header and extrinsics. And with header, it's pretty straightforward because all blocks on substrate chains, they have like same format for header. But extrinsics, they are like, they require custom types, basically, to be decoded. So if I send block without extrinsics, like, just empty array and a header, it works okay. And it can be decoded back. But yeah, extrinsics are problematic, so we need probably a way to convert it to hex without using polka.js. Like maybe I will reverse engineer how they encode it. And another issue was
let's talk about that actually. So hold on, let's just discuss that for a sec, Serge.
Sure.
So let me make sure I understand. So we get JSON over the HTTP RPC or whatever that is endpoint, and then there's a way to take the JSON and basically convert that into what Substrate or Polka.js thinks a block is. That's a signed block, and then there's a method to take that into some, I guess, more compact or more efficient binary representation of it. But in order to do that, we have to decode it. And to decode it, we need the types, and we're trying to avoid having all these custom types for all these different chains. So is there a difference between the final like to hex from signed block in terms of like size or complexity versus just what we're getting over the wire? Or are they the same?
What do you mean under the wire?
Over the wire, like over the HTTP API. Is that a different binary?
Over HTTP, we get JSON. Or you mean buffer?
Whatever the data is, I guess, just the data of the block. It's in JSON versus in the final representation. Sorry, go ahead.
Yeah, we get buffer, but it's a different one. It's a stream of bytes. But it's a different one. And it contains more stuff than just a block. It's like the whole response. It contains like the version. We only need result from the response. So the way Polka.js does it actually accepts JSON and it extracts result, and then they decode result. And if you need, you encode it back.
Nazar, did you have something you wanted to say?
You're muted.
You're muted, Nazar.
Sorry. I'm just opening Polkadot.js and trying to make a query and see what it actually returns. I suspect it might return actually already encoded data. So I might just forward it, but I'm not sure if that is the case. So yeah. RPC calls, chain, get block. Okay, let's say the latest one. Yeah, so it actually returns you like partially formatted data. It returns you an array of extrinsics as pieces of binary.
Yeah.
And it returns you logs as pieces of binary and extrinsic root as pieces of binary. So like everything is essentially binary. I'm not sure you actually need types to put this binary together into the block. It's like already encoded. Just need to like.
Yeah, it's
smash
encoded,
it
but
together.
we need to convert it to this hex.
It's already in
right?
hex. Like hex is just a binary represented as a string. So if
No,
you
but
like
it's
look to
a
browser
JSON.
console,
It's a JSON with like extrinsics are encoded. Header is not encoded.
Everything is encoded. So this is what it looks like.
Yeah.
What we get. So this is already binary, and this is already binary. But it still has like some structure to it.
Yes.
You just need to put it together. Don't need to decode it necessarily, I don't think.
So how do we put it together?
That's a good question. But the point is that it's already encoded in hex in binary.
Yeah, so what I tried initially, I tried to decode everything and encode it using this method from signed block. But yeah, it requires custom types. So I will try to find a way to maybe like encode it to the final hex without decoding it first.
I think we don't need to do any of that, actually. I think that's overkill right now, because the data is the same. Like whether we, like if we want to parse this and turn it back into a block, we can do that after we retrieve it from Subspace, right?
No, that's not the point. This data will be twice as big as what we store. Because every byte is encoded as 2 bytes. This is why it's hex.
Oh, okay.
And we have like these text fields on top of that, which we don't need.
Okay.
So that's basically why.
Is this blocking the implementation, or is this an optimization?
I guess we can store this JSON. This is like take.
Yeah, we can store JSON, but it depends how are we going to retrieve the block, and what are we doing? What are we doing with the block when we retrieve it? If we can retrieve a block as a JSON, that's fine. But I assume that since we're backing up other blockchains, there has to be like a way to, I don't know, include this block into the chain, right?
Yeah, I mean, like some substrate client of that blockchain or that parachain would retrieve this from the Subspace network, and then they would need to parse it into the format where they could import it into their block pipeline. But that's something which, like, now the custom types can be pushed into the end user, that problem, right? Mm-hmm. Versus like us having to kind of filter it correctly.
Well, if it's okay, we can store JSON for now. That would be much easier for me.
Yeah, I think this is one of those things where like we're still getting the right data in. Maybe it's not the most efficient representation of the data, but that's okay. To keep sort of getting to the end-to-end workflow correct here, and then we can always come back in and re-optimize this to get it to like reduce it by 50% in size.
Okay.
I agree.
Let's just make like let's capture this. Like let's make a a ticket and put it into the backlog to make sure that we don't forget about this. But I don't think we have to fix it right this moment.
Okay, noted. Another issue was so I'm subscribing to, for the parachain blocks, I'm subscribing to on finality hosted nodes, and sometimes they do not return blocks. They just return null. But the status code and everything is like 200. Everything seems fine. So maybe it's just I could find public APIs only on finality. Maybe if I find others and try others, it will be better. But yeah, eventually we will have
retries. Does it return data eventually? Maybe you just hit a node which doesn't know about that block for some reason, but I'm not sure how it can possibly be that it's finalized, but some nodes don't know about it. It doesn't make sense.
Yeah, I can try retry. Or yeah, but eventually, since it's just a HTTP request, I think we might have same issue with other nodes.
But that's fine as soon as we know that the block will eventually appear everywhere.
So
like
how do we handle this? If it's if we get null, we just retry until we get it?
Yeah, we retry with some like exponentially increasing interval or something.
Okay, I can try that.
But so you are trying to get blocks which were finalized by relay chain, right?
Yes. So
that is
it can be null. Yeah, it should be something.
Yeah.
I think it's just a server problem.
Yeah, maybe they just have a big lag in data for some reason.
Yeah.
So you're using the on finality nodes, you're not talking to the actual parachain networks themselves.
No, because on Polkadot.apps, I can only see endpoints for WebSocket connection, but for HTTP, I was trying to guess what would be like for HTTP, but it's not. Yeah, it's not public. So most of them, but on finality they have particular pattern. So I just yeah managed to discover what are the endpoints on finality.
Interesting.
Okay, and is it? I guess we were just going with HTTP because it was easier to set up than WebSocket connections for these different networks.
Right.
Okay.
I think errors will happen either way, so you still need to support
Yes.
retries. So I guess you can just add it. Maybe add some like monitoring if you have retries, how many retries and how much time it took for you to actually get the block, so we can like be aware of how bad it is. But I would imagine if someone would run such a relayer, they would connect it to the trusted node that they manage, and that node shouldn't be so much.
Is this, Serge, is this something that's blocking this PR, or is this just on the on the substrate side, or is this like everything kind of in one, like the node app as well?
Sorry, I don't get it.
So the previous question about decoding, well, I guess that was actually that was the same. Okay, I guess I thought we were talking about the things specific to like palette feeds in this one, but I guess we're just having a whole discussion on relayer now, which is okay because I don't want relayer to be blocked. If you need to jump off Ozgun, you can. This is like not related to the backend protocol at all now, and I know we're over time, so feel free to drop off.
No problem. No.
So, okay. So there's a couple of things here. So one is we're trying to get a partnership going with On Finality, maybe to the degree where we're going to have like a Discord channel with them, just like we do with Monk, like how Leo was working with them. So this is useful. This is something I can take back like to their CEO and say like, hey, we're trying to build an integration with you guys right now, and it's not working. Can you help us fix it? And this is like a good way to start like a partnership here. So that's good feedback. Have we done anything? Like, have you reached out to their support about this at all?
Not yet.
Okay.
I just discovered it today, so yeah.
Okay. Okay.
And I think I want to try with other nodes, like not just hosted on Unfinality. If this is maybe like this pattern is not just about Unfinality nodes. I want to make sure it's on their side first.
Okay. So I would say probably you should implement a basic retry, but if it fails, it's okay, because this is not a production ready live network, right? And I would rather that we just identify these bugs and push them to the backlog than spend a lot of time trying to make it perfect right now. So this is one of those things where, like, if it fails, then we just need to note it, and we need to think about how we're going to fix it going forward. But I wouldn't want you to spend a lot of time like trying different nodes, or like trying to get it, like, guess what it would be over HTTP, like to connect to these parachain networks directly. So and just in general, like as we move through this process, let's try to identify like these shortcuts. It's not even really a shortcut. It's just like, okay, we know this is a problem. We know we can handle it, but it still fits within the architecture that we have. We're going to move on to the next problem, like in the architecture, and then we can come back and like upgrade these things as we as once we have like a working demo, right? Like we're building a demo. That's kind of the key point here. We're not building a production ready app.
Yeah.
And go ahead.
Yeah, I wanted to say that this Unfinality issue, it's not blocking the actual final implementation, but yeah, this JSON binary submission, it was blocking. But since we can submit JSON, it's unblocked.
Okay, great. The other thought here is that if like, it's okay for this like trusted relayer, like version 1, for it to be an Unfinality, but as we think about the architecture going forward, especially as we want to move to a trustless relayer, then we would definitely want to, if it means we have to upgrade the connection to WebSockets and connect to all these different, like have like stateful connections to all these different parachain networks, then that's probably what we need to do, because it's like not within sort of the spirit of what we're trying to do as we improve this.
Yeah, but the reason why we didn't connect to WebSocket is because if we use Polka.js, we need custom types. Otherwise, we need to implement our own like WebSocket client, and that's a lot of stuff to do to re-implement.
Okay. Well, we can save that discussion for a later day, but I'm just saying we probably need to figure out a way to make the relayer work without having to talk to like a server, but to actually talk to the blockchain networks themselves, whatever solution that may be. Okay. Okay.
No, but it still talks to RPC API.
Yeah, but it's talking to like, it's like the difference between connecting to the Ethereum network and connecting to like an Infura hosted node of the Ethereum network. Like that's kind of like what we're doing here. It's like not really, like it's not really fully decentralized. I mean, it's the same RPC, but it's not the same like way of plugging into the network.
No, but every node, even local node, has RPC API. This is how you interact with a node.
Right.
So
I guess.
You mean Unfinality is like Infura?
Yeah, like Unfinality is like basically a bunch of nodes like running in AWS that like people are paying to like host on their behalf. It's not. It's not. I mean, it's probably not even the nodes like for whichever parachain they're probably paying Unfinality, or I guess it's free right now. But Unfinality is running some nodes for them, but they're also like they have a volunteer network of nodes as well, and we want to plug into that volunteer network, not the sort of centralized nodes. That's really what I'm getting at here.
Understood.
Okay.
But we still need to connect to some node, and chances are that node will be a hosted node by someone. Or we can spin up a local node.
We could do either. We could also connect to a hosted node and then ask for its peers and then connect to some other node, like you're talking about, like a bootstrap node or a gateway node. That's what we should eventually work towards as it becomes more decentralized.
Okay, this is something we can discuss later.
Is there anything else that's blocking Relay right now, or any major issues?
So I'm currently working on this parachain integration, and yeah, I'm having nonce issue, and I think I will start introducing multiple accounts, so as a workaround for this nonce issue, and we still need it for proxy accounts.
But why do you have nonce issue? Why can't you like sequentialize it or something?
Well, it used to work previously, but now it doesn't. So I don't know.
Feels like it's racy.
It complains and the account submits too many transactions in the first, like in the short term.
Okay.
But this is where you've got one account that's doing all the transactions.
Yes, currently I use only one account.
But whenever we do the proxy accounts, that's going to take care of that, where we're just going to have like one.
Right.
So do we still need to implement a workaround, or can we just go straight to proxy accounts?
Yeah, but proxy is just accounts that have like this ability to spend money from other accounts. But essentially, those are just accounts. So I will create some accounts, and or maybe use some dev accounts with existing balances. And then we can, next step will be make those accounts proxy accounts. So we can spend money from like Alice account.
Doesn't each proxy account have its own nonce?
Yeah, they will have same nonce. Yeah.
Same nonce or different nonce?
Different own nonce.
Okay. I mean, it feels like if that's, I mean, that's the whole problem that proxy accounts are solving. So I guess I don't see why we need to have multiple accounts and proxy accounts. It would be
Proxy
either or, but
accounts
not.
are multiple accounts.
Yes, it's just
The
you
difference
just
is whether they have own balance or they are spending someone else's balance. That's the only difference.
yeah, you
Right.
just delegate to proxy accounts so they
But
can spend your balance.
But you're saying that you want to create multiple parent accounts and then proxy accounts underneath those.
No, it's just all of them are basic accounts. Just one account can delegate to other accounts spending funds.
Right.
But essentially,
Okay.
they are all accounts.
I get that they're all accounts, but I guess I thought you were saying that you were going to create like an Alice and a Bob and a Charlie to prevent this nonce conflict, and then you were going to create proxy accounts, so like Alice could have like 5 proxies, no. Bob could have 5 proxies.
No. So by the end of the day, we'll have account Alice, let's say, and other accounts, Bob and Charlie, they will have this. They will become proxy accounts, so they will spend money from Alice. But as a first step, I will just use Alice, Bob, and Charlie as equal accounts without this proxy connection.
But that's
you're
what I'm
talking
saying.
About
I guess
the same thing. You're actually talking about the same thing, just different words.
No, we're not talking about the same thing. No. So I guess I don't see why we need an intermediate step. Why can't we just go straight to proxy accounts?
Because you need separate separate accounts, whether they are proxy or not. So we can implement separate accounts first and then transform them into proxy. The logic working with accounts will not change from that. It's just another layer on top.
But it's not. Sorry, go ahead.
To make them proxy, you just need, Alice needs to create a transaction. So without transactions, they're just normal accounts, independent with own balances. But see, after Alice submits a transaction, like Bob can become a proxy account of Alice.
Okay,
so
but
first step will be just create multiple accounts without this transaction by Alice.
But it's okay. Maybe I'm not understanding, but I feel like we're creating extra work here, because if we, like, I guess it really depends specifically on how you implement this. But if you, so when you say create multiple accounts to start without proxy accounts, do you mean that's like in the chain spec, or are you creating those dynamically in the app, like in the Relayer app itself?
By the end of the day, it should be dynamically.
Okay, but then if you make that work without proxy accounts, you also have to send money from Alice to those accounts to, like, if you're doing it dynamically, you have to create the, basically you say Alice, send 100 to this, to Bob, 100 to Charlie, 100 to Dave, whatever. But if you have proxy accounts, you don't have to do that, right? You just create these, you dynamically create these accounts, but then they can spend Alice's funds without having to send them.
No, I will use accounts which are in dev mode already have funds. So I don't have to send money from Alice. Like dev accounts.
So
I guess
the
I
first
just
step
feel
would be to not use dynamic accounts, but use those as for simplicity. But then those will be switched to dynamic and plus transaction.
And dynamic will have like this delegation transaction.
Okay, it just feels like if we're adding a step where we have to create them in the beginning, and then we're going to remove that step and create them dynamically, then why not just create them dynamically to start?
Not having a step, they're already there. Like Alice, Bob, Charlie, Dave, and whoever, they're already there by default.
Yeah. Okay.
So you can just test it with like 2 parachains right away.
Yeah.
Well, but is that what we're doing? Are we just testing it with 2, or are we like implementing it for like 10 or 12 different parachains? Because that's like a non-trivial amount of work to do just to get like an intermediary step. I guess the point I'm getting at, I'm trying to say is we need to move faster, and I'd like to not have to do a bunch of intermediary work that's just going to get refactored out. Okay. It won't work.
It is not work. It's something that's already done for us.
Okay. I mean,
so you can actually start testing multi-accounts before you even have a mechanism to create those accounts by using those that are predefined. The next step, you add creation of those accounts and transactions. So this is like a gradual upgrade. It's not something that we do and then throw away. It's like already done.
But that's what I'm saying. We are throwing it away because we're not going to have in the first version, we have to create all these accounts. Like, okay, we have 100 parachains, right? That means we have to create 100 accounts at Genesis.
We are testing 100 parachains tomorrow. Tomorrow we'll test 2. And by day after tomorrow, we will have dynamic accounts and this question will no longer exist.
Okay, as long as we're clear that we're testing it for 2 and not everything that we have right now. That's what I'm trying to get at. I feel like we're going to test it for everything that we have, and then we're going to refactor it for everything that we have.
We are talking about like 2 days plan, not like a month.
I mean, well, we're behind schedule already, and these things are taking longer than expected. So I'm just trying to get things moved. Like I'm just going to be like very clear. Here's the bottom line. Like, we cannot start fundraising until we have LOIs from parachains. We cannot have LOIs from parachains until this work is done. And it's going to take several weeks to get LOIs from parachains once this work is done. So I'm just trying to make things move faster and simpler rather than like doing it in this very like sort of, I don't know what the word is, but it feels like we're making it more complex. We're adding more work in than we need to. So I'm just trying to get to a version 1 more quickly.
I think it will be
fine.
I
understand the importance.
Okay, cool. I think we beat that dead horse enough.
I think at this point I can just say it. We probably shouldn't have talked about all of this on the recording, so we'll have to cut it.
Probably not. Yeah, probably should have stopped recording. Good point. Okay. All right, cool. Anything else, Serge, you want to cover on Relayer?
Yeah, I think all covered.
Okay, guys. Thanks a lot. Thanks for the long meeting. I know this was a lot of information. I think it's going to be shorter next time. now that we're caught up. Otherwise, I'll talk to you guys tomorrow.
See you.
Thanks.
All right. Bye.
See you.